everyone, and welcome. It is Wednesday, and the Knowledge Bolide crew has assembled for the 262nd time in a row. We've been going since 2020. It's ridiculous. Well, one of the new things that we do now for our Patreon supporters is we help them ID their rocks. Is it a meteorite? Is it not a meteorite? What's our best information that we can provide? So the Knowledge Bolide crew is a bunch of people who are meteorite enthusiasts, collectors, studiers, scientists, enthusiasts. There's 200 plus years of experience and thousands of samples in our collections combined. We know what we're talking about, and we're here to tell you either divorce yourself from this rock, it's terrestrial, or there's a little bit of something here we think, can go either way, or holy crap, can we hold your hand through the classification process? So that's the goal for tonight. We have 5 rocks to get through. All right, we are moving into a rock ID for meteorite or MeteorWRONG number 1.
Okay, so for the first rock of the night, we have a Rockhound Hunter supporter. This is the only one we're doing of this type. And this is where the submitter submits their own photos and video. And we have a rock from Epi Jr. So Epi is actually local. I think he lives maybe a half hour away from us. And he was actually out hunting for gold at the time, out in Tonopah, Arizona. And this is a really perfect place to actually go meteorite hunting, coincidentally. So fingers crossed for him. So for our Rockhound Hunter supporters, they do their own diagnostic testing, whereas with the white gloves, Topher does the streak test and the magnet test himself here on camera. But sometimes they just give us the results. Other times they do it on camera, which is what we prefer, and that's what Epi did. And he found that it had a moderate attraction to a magnet, and it did leave a white streak behind.
So definitely keep these facts in mind as we go through his sample.
Okay, so we always ask our, both types, the Rockhound Hunter supporters and the white glove supporters, to please let us know what you believe that you were looking at as far as meteoritic features. So as I was saying, I told Topher, this was pretty funny. I said, Epi told me that he was out hunting with his My Gold Big 2 metal detector. Topher is like, that's not what it is, Sue. Isn't it Bug 2?
Yeah, gold bug too.
So he was hunting for gold. So he did find it's a small rock, has some small visible black metal flecks on the inside and outside of the rock, and also he reported fusion crust and contraction cracks. And it's really important. We have a survey that all of our submitters fill out. It's really important that people fill that survey out and tell us what they think they're looking at, because that helps us get into their mind and see it from their perception, and it also helps educate. All right, and then the last question on the survey that we always ask everybody, and believe it or not, some people try not to answer it. They just say, I don't know. And I always tell them, no, you're not allowed. You have to tell me what kind of meteorite you think that you're seeing. So Epi believes that what he found was a Martian meteorite. And he actually did compare it to a specific Martian Shergotite, NWA 12241.
I was going to say that information is really helpful because there's so many different types of meteors. There's like 300 different classifications of meteorites, and they're very granular. But tell us what you think it is. That really narrows it down, and it really helps us remove a lot of the rice off the table and focus in on what we need to.
So what we have now are going to be 5 photos. And I want to remind everybody, when we ask our Rockhound Hunter supporters to upload photos, we ask them specifically, please rename these files with what you believe you're looking at. So those descriptions of what you're seeing on the right, those are from our submitters, not from me and Topher, but from them, and what they think they're seeing. And then we have a 2 to 3 minute video after these photos.
All right, so the crew has examined this video. We've all had a chance to talk about it amongst ourselves, and the four people we've chosen to talk for us, our mouthpieces, if you will. Allison, what you got for us?
Yeah, I see that this actually does attract a magnet, which I that surprised me a little bit because it doesn't look like it would. I don't see any shiny metal flecks in this. The submitter here says that they see black shiny metal flecks, and I'm just not familiar with Martian in particular having metal in it, but um, I think Pat had some information about there's a possibility of there being some unoxidized Martian metal. I'm going to hand it over to Pat because that's about all I have to say about it.
Yeah, so typically metal does not occur in planetary meteorites and lunars or Martians. If is any metal, it's part of the impactor because they're all differentiated. I've done a little studying on Martians and looked at several, and really for these achondrite rocks, the only way we have of really identifying them, noticing them in the field is fusion crust. And typically Martians have beautiful, black, shiny fusion crust.
Yeah.
So I'm not seeing anything like fusion crust on this one, possibly a weathering rind. And you can only have contraction cracks if you have fusion crust. And that's what I have. Thank you.
So do you think that the texture of those contraction cracks are caused by the granularity, the crystal grain of the rock?
Yes, I think just weathering of the rock.
Thank you. Appreciate that. Dave, before we send it over to Mike Kelly for closing, what do you have for us, sir?
So what is really common in the desert, and this is kind of where it came from, is what's called the caliche. And it's kind of this carbonate whitish material that coats a lot of the top of rocks. And this looks like it has it because underneath that looks like it's a different rock. And if it was a fusion crust, it would be more shiny. And this is just really rough and it just crumbles when you go on the porcelain. So that's what I got.
Thank you so much. And that leads right into Mike Kelly. What you got for us, buddy?
While you're looking at the streak test, it looks like a cream color, right? So Martians are typically a lot of olivine and a lot of pyroxene. Olivine is going to give you a whitish streak. Pyroxene is going to give you a whitish to gray streak. So I'm not seeing the streak color there that would say it's a Martian. I'm also seeing a lot of material build up on the porcelain. So that's a very soft material. Sure, there are soft meteorites out there. You know, you get carbonaceous mud balls, but Martians, right? You're escaping from a planet with high gravity. That means you need to be a really solid rock, right? Very porous, low density rocks would not survive that. That's why we don't have sedimentary meteorites. Um, so that rock looks very light and porous to me. I got a feeling it's a terrestrial volcanic, maybe like a rhyolite or some other lower density extrusive flow based on the fine graining.
Awesome, crew. Thank you very much. I value everyone's opinion, and that is the crew consensus. We talked about this before. We watched the video, we got our information together, and we are in agreement that unfortunately this if this was a sample that we found out in a strewn field, we would probably leave it there. It's not one that warrants any further investigation in our assumption. So. I also want to thank our Patreon members who aren't Rockhound supporters or White Glove supporters. You can be a witness supporter for $10 a month and still have access to almost every single video out there. You can even join as a free person, a free member. Believe it or not, there are some stuff that we put out there, some education, some summaries of our hangouts that are available for free. So please go out and join. I think we have 325 people right now that are joined. I mean, the vast majority of them are free members, but I don't care. Let's get that up to 1,000. I don't care if we have 1,000 free members.
We also have a level, tier level for educational, and we have the supporting and the VIP tiers on YouTube as well.
Wow. Okay, so Sue's been doing a little work on the slide deck.
He was mad that his head wasn't bigger. He's like, I want it to be huge, so it's like a bobblehead. So it's bigger than I wanted it to be.
Yes.
Now
No,
you can mute it.
I am not that fancy of a man. You guys know I don't wear white gloves, even with real bona fide meteorites, unless the owner specifically tells me I'm not allowed to touch it unless I wear this pair of gloves. Then I'll put that pair of gloves on. Otherwise, let me at it. All right. All right. We are moving on to Meteorite or MeteorWRONG number 2 and number 3. And of course, who does number 2 work for? So these are both sent in from the same person. We're going to introduce them separately and look at them separately. That way we can have our thoughts clean and clear about the one sample. I don't want to confuse the two of them together. Sue, could you tell us what these are?
That is correct. Yes. So the next 2 rocks are from Travis. He is a returning supporter. Okay, so the first rock or specimen that Travis submitted to us was, and they're both of them, but found in Northeast Ohio. It's really important for our white glove submitters to label the rocks and make sure they fill out separate surveys for each rock, because I know they were both found in Northeast Ohio, but I'm not exactly sure if they were both found on the shore of Lake Erie or in the blue clay like dirt, but I went ahead and ran with it. We have a rock here, yep, that weighs about 57, 58 grams. Okay, so as we previously mentioned, we always ask our submitters to tell us what they are seeing, what meteoritic features, and I give them a whole list and ask them just check off the boxes. So Travis reported shiny metal on this specimen. And this feature led Travis to believe that he has an iron meteorite. So now we're going to kick it over to Topher for live show and tell and testing. And that is going to be testing the attraction to a magnet and doing a streak test.
All right, we are going on to Meteorite number 2, MeteorWRONG number 2. We've already been, again, as a crew, studying this and talking about it offline. We have 5 people who to get us start. Wait, Allison, what you hope? We have 5 people, and then or 4 people, and then Allison just interrupts me. What do you need?
I was just going to ask if you could do a streak test and a magnet test for us on that.
Oh, yeah. Sweet.
Because a strong magnetic attraction, a medium magnetic attraction, and a weak magnetic attraction all tell us really different things.
Yeah.
As does a streak test. So. Oh, interesting.
Yeah, it's not really. Wow, it's.
Oh.
Yeah, it's not really that. It's same attraction throughout. It's homogeneous, but not very strong attraction whatsoever. And I'm going to do a streak test while you got me doing it. And Allison, thanks for reminding me because I don't see anything. I don't see any color whatsoever. Well,
did it come off on the rock?
Keep in mind too that remember I read that like not all streaks are visible and like sometimes you have to look under the eye loop.
Okay, so it's a hard stone.
Yeah, it's a very hard stone. All right.
With a weak magnetic attraction. All right, thank you, Topher. That says a lot. Right.
Awesome. No, wait. We have Travis in the house. Travis, what do you have for us, buddy?
So taking a look at the rock here, Travis submitted that he found it along the shoreline of Lake Erie and calls it a iron meteorite. Water and iron don't mix very well and cause items to rust or cause iron to rust, and I'm not seeing any rust on this at all.
Yeah. Yeah, that's a good point. Yeah. Yeah, I don't see any oxidation orange browning staining that we always see in meteorites that are cool. Thank you very much. Dave Pinsky, what are you seeing in here?
Yeah, on the smooth side is a very indicative of what river rocks look like. So when they're water's going over them and they're getting tumbled, it smooths them over, and you can see how one side is kind of rough, that's broken, and water and other rocks that it's tumbling around will do that. So that looks very much like what they normally would call a river rock. That's
Awesome.
what I heard.
Thank you. I'll also add on to that, if you don't mind, that the outside, because we always, I'm comparing the outside texture and what I expect to see and feel in a meteorite, and I don't feel any metal. Like, it doesn't feel like metal. It feels like silicates, even on this broken texture. Pat, could you talk about that or
Yes,
anything?
yes. So, Travis noted the absence of rust, but the other thing we can look at for determining whether something is metallic or not is how it fractures or how it tears. And on this broken side, we see a very clean fracture, which we just don't see in metal. I think this is an igneous or volcanic rock. And on the inside, there are a number of crystal faces that we can see as it's rotated around in the light. And so
Yes.
that tells us that it was a volcanic rock that cooled relatively slowly to have enough time to grow crystals. And Topher also showed us this one versus a metallic meteorite of about the same mass, but look at how different the volume is on these. So the submitter's rock is much lower density than we would see in a nickel iron meteorite.
Yeah. Thank you very much. I really appreciate that. Yeah, it is striking when you say that this is 57 grams and this is, just under 60 grams. It's a Gebel Kamil. It is an iron from Europe, not Europe, Egypt. Um, and as you can see, it is dramatically smaller, but still the same mass, the same, 60 grams or 80 grams, whatever it is. But yeah, this is way smaller, so definitely a lot less dense material. All right, well, we are going to call this one, and the crew consensus says it is not an iron meteorite. It's way too small. There's no real metal in here. There's no oxidation. There's no weathering. There's no rusting. It doesn't break correctly. There's crystal faces that are all shiny in there. As far as we're concerned, we're not seeing really anything on here at all that talks to it being a meteorite. Especially not an iron meteorite, as you can see from the density, the sizing. I thought that was a pretty nice tell right there. Very educational. Okay, we were going to move away from this sample, but we thought, you know what? There's a teaching opportunity, a learning opportunity here. We saw the interaction between the non-iron meteorite and the magnet, the rare earth magnet. Now, here's it reacting with an iron meteorite. It is 100% night and day. That is like versus. So, Allison, thank you for pointing that out. It's another learning potential for us learning when we do the magnet test. And you think you have an iron meteorite and you get that reaction versus that reaction where it literally just jumps. So, thank you, Allison. Appreciate it.
Okay, so we have a second specimen from Travis, and I can tell you that this was found in Northeast Ohio. Like I said before, I'm not sure which of the rocks, or if not both of them, were found on the shore of Lake Erie and found in the blue clay like dirt. This one is a little heavier. It is two pieces. Usually, we don't allow people to send multiple specimens of the rock, but we could tell that there was no doubt that he did cut them from the same rock. So it's 147 grams altogether. So we did ask Travis to let us know what meteoritic features he believes that he was looking at, and he said that it was a fusion crust and chondrules. And I did help him out a little bit on this one. He said, I don't know what kind of meteorite it is. So I'm not going to take a guess. And I'm like, well, what kind of meteorites are chondrules in? That would be an ordinary chondrite. So we didn't go deep into if it was an H or an L or an LL, but yes. So the final guess was chondrite, ordinary chondrite, and
Just
just
no.
I was about to say that.
Okay, go for it.
So Topher's eyes popped out when he saw this. He's like, "That's not Travis's specimen, is it?" And I'm like, "No." I said, "Usually these screens have planets and other meteorites and things like that, but for some reason this time that didn't register with him." And I said, "No, that is just an ordinary chondrite in the background. That's not Travis's specific specimen." And then I reminded him, "This is a white glove. We didn't get photos of it, remember? You're going to show it to us live."
So let's look at his live specimen now. All right, the crew has analyzed these samples. We've done a scratch test, which we will redo live, and we did a magnetic response. I'll do those here. We already have 4 volunteers. The first one is Travis. What do you have for us, Travis?
So this is a nice looking rock. I like the looks of it. One thing I'm noticing about it though is it is both black on the outside and on the inside. And typically we would see different colors looking on the inside from the outside there.
Yeah, that's a good call out. We always want to see a difference on the a difference on the inside and outside, and we're just not seeing that in this sample. Thank you. Ben, what do you have for us, buddy?
In regards to the outside, it looks water worn. It doesn't look like an ablated surface from coming through the atmosphere. Yet there's all these pits and nicks in the surface. I mean, all over. Yet not one exposed chondrule. That's highly unusual.
Yeah, I appreciate you pointing out the outside because to the untrained eye or to the the untrained, if you haven't held enough meteorites and looked at them up close, you just can't tell sometimes. But so I could see someone looking at the outside of this and saying, "Wow, it's really been ablated. Look at it almost looks like it's dripping right over here." So I appreciate you pointing that out. It has no magnetic response whatsoever. So it would have to be a chondrite without metal, which doesn't exist. Um,
Too hard for carbonaceous.
yeah. Ben, was that your comment? Did we satisfy you?
Yes.
Thank you very much. I appreciate it. Allison, what do you have for us on this one?
Yeah, the definition of the word chondrule is little round grains. And that's a very hard rock, harder than we would expect a chondrite to be if it's removing pieces of the tile. So our streak test is telling us a lot there. But when we look at the inside of this, we see there's a round one down there by your thumb, for example, roundish anyways.
Yeah.
But when we talk about chondrites, we expect to see those round things cemented in there with other round things, which are cemented in there with other round things. And even some of the metal blebs and the metal in chondrules will go around the chondrites, so it'll armor the chondrites or be little round metal blebs. And so while there are a couple of little round things in here, there's just not enough to satisfy chondrite, nor is there metal behaving around the chondrules as we would, or intermixed with the chondrules as we would expect to see in a chondrite.
Yes, thank you very much. I think the last person we want to go to about the inside of this was Pat, who's going to talk about the internal structure. I want to make a comment that, and we're not giving the guy a hard time whatsoever, but it looks like obviously not a smooth cut. It looks like whatever tool he used, this rock resisted pretty well. So it seems like a very hard, dense rock, and that's played out in the scratch test. I just wanted to point out to everyone that this is an internal surface that's been hacked on, and we are not looking at any flow features, nor were they claimed to be flow features. But I thought I just don't want anyone's attention to get distracted by that, because that could be a very good looking flow feature of a meteorite. Pat, over to you.
Yes, so this is obviously a very hard rock. It looks like it was cut with an angle grinder with an abrasive blade of some sort. But so ordinary chondrites have a lot less matrix, the thing, the stuff in between the chondrules. And this one is very, very high in what we would call matrix if it were a meteorite. But the carbonaceous chondrites are that way, but they're extraordinarily soft.
Yeah.
So we can see that this is a very hard rock. There's very few things inside that look chondrule-like at all. And the black stuff between the matrix is extremely hard. Yeah, so this does not look like a chondrite.
In your opinion, let's see if Dave Pinsky agrees. Dave, you're closing us out, buddy. What do you have to add, or do we steal everything?
Pat stated that beautifully, and let me add that if indeed that was a lot of matrix, and it was one of those weird chondrules that just had a very few chondrules and a lot of matrix, the matrix would have thicker or more coarse grain. The grain on this is almost microscopic, almost glassy, and that is never in a meteorite. You would have to super polish one, and even then you can see a heavier grain. And this one is very, very hard with a very, very glassy type of a grain. That's what I got.
Thank you very much, Dave. I'm going to close it out with one other observation. This is how we watch iron in meteorite slices show themselves off. I don't see anything jumping and flashing at us like we always want to see that chrome bumper metal, and we're not seeing it. So I don't see any metal in this one. I just want to point that observation out. Now to the crew consensus. All right, crew consensus. We kind of all agreed that this is a earth rock, a terrestrial rock. Definitely not worthy of spending more time on, more money. It would, if we get it cut really flat and put a nice shine on it, it may be pretty as far as reflectivity goes, but there's no meteorite features in this stone that the crew's picking out at all. So I hate to say it, we had another swing and a miss, but this one is a terrestrial rock, and we're pretty confident on that one. All right, it is now time for Meteor Wrong number 4 and 5. Let's take a look at these submissions.
Okay, and these submissions came to us from Sean, who is a pretty well-known member of the meteorite community, at least on the Facebook community for sure.
Yeah.
Okay, so I didn't necessarily want to refer to Sean as a first-time submitter, but this is his first submission and second submission tonight, but he has been a long-time supporter. Actually, every few months I ask him, you gonna ever send a rock our way? So finally, we have some rocks from Sean, and these were both, I believe, found in like kind of urban areas. The first one most likely found up in Northern California's Central Valley. I believe it was found in Stockton, or at least close to Stockton. And it was just something that he noticed in a pile of landscaping rocks at the grocery store. And I guess it really stuck out compared to the rest of the rocks. So he picked it up and took it home. So we did ask Sean what meteoritic features he believed he was seeing. And he reported weird indentations. And then within those indentations, he was seeing little metal flecks. And he also said weird vugs with a strange material behind those as well. And you'll see what he's talking about when Topher shoves this off live.
All right, this is rock number 4. And again, the crew has been looking at it, talking about it, and fighting to share that feedback with you. But I can only share it from 4 people. So Anthony was one of them. Anthony, what have you got to say for yourself, buddy?
Yeah, so I'll just comment a little bit on the interior of the rock. And if you look at it, right, it looks like some kind of fine-grained material with clasts or inclusions or something that grew in there. So I'm gonna guess it's some kind of like basaltic rock. Because I found some like that had similar look to it with those inclusions, right? It looks like it's something that grew in there, not a part of a breccia or something or a chondrite, right?
Gotcha. Yes. And there is no magnetic attraction whatsoever. So that
And if
proves
I could
it.
just add real
Yeah.
quick, the interior looks very similar to the exterior, which I believe Boris has something to comment on.
Oh, sweet. Go for it, Boris.
Yeah, so we see a lot of rocks like this that are kind of baseball size, very well rounded. And you look at the texture on the outside, right? It's well rounded, it's been abraded. It looks like it has some divots or some fractures. It's very pitted, and it's been really, really well polished. I mean, this thing is almost reflective, right? So this thing has been weathered around a lot. All those little points and divots that you see, those are little percussion points where other rocks have been smashed up against it. And this is just highly characteristic of a rock that's spent a very long time being rolled around against other rocks, probably in a river. So this is sort of all the external features of a very well-rounded, very well-polished river rock.
Wow. Thank you very much, sir. I appreciate you joining the conversation. Allison, what did you want to talk about? Because I'm looking at this. You don't have to talk about this if you don't want, but I'm looking at this break, this crack.
Sure, we
Is
can
that what
talk
you'd
about the
expect?
crack.
Is that what you'd expect to see in a meteorite, or
Um,
what were you going to talk about?
Well, and I'm sure you're referring to the way that has cracked. It is almost a conchoidal fracture there,
Yes.
which is indicative of a really hard rock. But what we don't see inside of that broken face, or in the cut face, or in the outside, is metal blebs. Did you do a magnet test on this?
Yeah, it just literally rolls right off.
Okay, yeah.
Yeah, I mean I would this is the most unresponsive rock I've ever seen.
All night, the most unresponsive all night for sure. Yeah, I don't see any metal flecks. So, and
Wow.
also, if we have metal flecks in a rock, we would hope to see some sort of magnetic attraction.
Thank you very much. Dave Pinsky, what do you got?
Yes. Okay, so in addition to the complete lack of chondrules, again, the size of the grain on that, and even since the outside is the same as the inside, on some of the areas it's almost like a glass, which means there's very, very tiny grains in that. You would probably have to have a very strong microscope to see any grains in that. And that's not like what a chondrite would be. So that's what I got.
Thank you, man. I want to look at it from this angle right here. And if you showed me something like that and told me, wow, I got a new iron meteorite, and you crop this the right way, I could buy that. A little bit of the features do look like an iron meteorite. When you look on the interior, you do see, Anthony was talking about the incursion of those minerals that look like they grew there. They look similar to CAIs. The shape, the weird size of them and everything. But if you think about CAIs, they have to be in a carbonaceous meteorite. And this is not a carbonaceous meteorite. There is no way a carbonaceous meteorite, as Boris put, would take the beating of its life in a river, getting pummeled with other rocks. It would be a mud ball in a weekend. So this is not a carbonaceous meteorite. Okay, the crew consensus is we have a very large water-rounded earth rock. It has no magnetic attraction. It has no magnetic response. So we know it's not a chondrite. We see things on the inside that may look like CAIs, but they only appear that way in carbonaceous meteorites, and this cannot be a carbonaceous meteorite due to the beating it took in rounding in water. So I feel we're 100% on dot with this one. It's a very interesting looking, if you photograph it from certain angles and show it off certain features, you can confuse or convince someone that it's meteoritic in nature at certain angles, but the crew has nailed it as a terrestrial.
Okay, so we have a second specimen from Sean, and this is also the last rock ID of the night. This one weighs a little over 25 grams. And, the last one I said, I believe, was found most likely in Stockton. This one was found at a flea market that I believe was most likely in Stockton, but who knows where it came from because it is being sold at a flea market. So I don't know if it was actually found in California or found somewhere else. So I don't want to make any assumptions there. So we did ask Sean to let us know what he was seeing as far as meteoritic features, and he reported a fusion crust, shiny metal flecks, and he thought that the internal matrix kind of resembled Martian meteorite, as in like the light matrix with little flecks and specks in there, the darker ones, which we've heard on more than one specimen tonight. So that led Sean to believe that his specimen might be a Martian meteorite. Topher, I'm going to hand it over to you so you can do some live show and tell.
All right, this is sample number 5. And I'll be honest with you guys, this one really caught my attention. I paused really quick to looking at it. The crew has been looking at it and talking about it and fighting about who gets to say what. And the first one selected was Travis. Travis, what were you going to say? I think it was talking about an observation that the submitter made.
Yeah, so on this rock here, I'm not seeing any metal flecks or any metal blebs. If we were seeing some metal, we'd probably see some flashes that would hang in there, just like a nice little chrome bumper. It wouldn't go away. And then I'm also on what would be the fusion crust. I'm not seeing any kind of flow lines or rollover lip or anything such as that.
Awesome. Thank you. There is a pretty evident feature on the outside of this that Boris pointed out before I did. I was actually looking at that thing. But Boris, what did you see on here that caught your eye?
Well, there's a line that sort of goes right around the top edge of the rock, and it doesn't look to me like a fracture. I actually think it's some type of a layering feature, or at least some type of an internal lineation within the rock. And actually, right around that little divot there, that light colored divot, there seems to be a couple more,
Yeah.
and they're parallel to each other. And that's
Oh,
just
yeah.
that's like a solid indication or suggestion that could be a type of manifestation of layering and some type of internal layering or lineation. So, and
Fantastic, man.
you don't really see that on meteorites. Unfortunately, this looks more terrestrial based on that feature.
Awesome. Thank you, man. I appreciate it. I wouldn't have noticed that. I looked at this one and I thought those were metal blebs sticking out, but there's no reaction to a magnet. And then on the scratch test, it's a gray color. So, Dave Pinsky, are you up?
Yes.
Okay.
The when you look at the, well, what is thought of fusion crust, when you look at the kind of the area where it's kind of breaking a little bit, it's all on the same level as the interior, which suggests it's some sort of weathering rind. And then when you just now did that scratch test on the fusion crust doesn't usually leave uh, that much of a mark on the porcelain. So there's some sort of weathering rind on top, and not a fusion.
Yeah. Okay. So the black we're seeing is basically a weathering rind patina that was added terrestrial to the rock. It's not fusion crust from a century.
Exactly.
Awesome. Thank you, man. I appreciate that. Our cleanup batter, Dr.
Yeah,
Pat.
so I agree with Boris. I think that line is, and the other lines there are indication that it's sedimentary, and we don't have sedimentary meteorites with a couple of super weird exceptions, like literally two.
Yeah.
And then I certainly agree that the black coating looks like it is far thinner than we would expect for fusion crust and not equally distributed on the rock. Uh,
Yeah.
if I was out hunting meteorites in the desert, I'd pick that rock up every day. On closer inspection, I do
Whoops.
not believe it's right.
Yeah. I'm glad you mentioned about picking it up or how it would look, because the crew kind of came to consensus that this area right here was down in the ground and protected, while the exposed rock got that patina, that burnt look, weathering that we were talking about. This part didn't, because it was in contact with the ground. So this gives us a true look into the rock, as someone said earlier. And yeah, I agree with everything that people have stated here. So, well, the crew consensus on this one is it is a very misleading terrestrial sample. Um, if the submitter doesn't want this in their MeteorWRONG collection, I know a few people who would probably want it in their MeteorWRONG collection. It looks from across the way like gold from space. But for the reasons we spoke about the patina and the weathering rind on the outside, the sedimentary features that we're seeing, and then the internal structure of it as well. No magnetic response. So we are going to rule this one as a very interesting and an off-putting terrestrial sample. But what's not off-putting is our in-house professor, honorary Professor Pat Brown, and you're going to share some information with us today. And I'm not even going to tell people what it's about. I'm just going to flip it right over to you, buddy.
Okay. So Martian meteorites are rare. Yeah, there's 200 or 392 of them on the planet, on our planet. When the rocks that we look at that have been submitted for Meteorite or MeteorWRONG, many of them are Martians, and that makes it a little extra difficult because Mars is made out of the same stuff as Earth. Mars is a fully differentiated body and planet like Earth. It's about the same size. Gravity is similar. Um, how do we identify a Martian meteorite? Well, it turns out that even for the experts, for the Martians, and then for all the weird ungrouped achondrites, they are really recognized by the presence of fusion crust. And in particular, Martians have pretty uniformly beautiful, black, shiny, glassy fusion crust. I mean, just gorgeous fusion crust. There have been three Martians found in the United States. We looked at them, and Sue and I talked about them earlier. They all have ultra fabulous fusion crust, and they were recognized because of their fusion crust. So one of the rocks we talked about was NWA 12241 that was used as a comparison on some of the other rocks that we looked at today. And if you look at the inside of it, it's pale, mostly silicates, a little bit of black spots of stuff, and that those black spots in 12241, after all of the chemical lab work and everything was done, turned out to be chromium-rich chromite, or possibly pyrrhotite, not pyrite, but pyrrhotite, which is another one of the metal silicates, mostly iron silicate, and dark with a little bit of a brassy sort of look to it. So can't really tell from the inside. So it's all about the fusion crust. And if the fusion crust looks good enough and it's a good enough candidate, then you go in for oxygen isotope testing. Now, the achondrites are tough. Martians are particularly tough. And in the lab, we can tell, but in the field, it's hard.
It's nice when we ask our people to compare it or see what they say. It gives us a chance to dig in and learn a little bit more of the science. So here's some interesting science behind this very rare Martian sugartite olivine gabbroic orthocumulate with low
Yes.
shock.
Yeah.
So
Say
it's a
that.
very, very spectacular and rare meteorite he's comparing it to.
And the reason that we know that NWA 12241 is what it is because of the lab work. The fact that we know that it's a gabbro of olivine that's orthocumulate, that it has low overall shock. We don't see shock veins or shock planes in it. But to the naked eye, the inside, it's a dull, pale, yellowish green sort of color with some white stuff and some little dark spots. So there's limits to what we can learn in the field before we jump to the lab.
Thanks, Pat. I appreciate you hitting on those notes and giving us that information. A little education there to put on the side of our rock IDs, because we don't want to destroy hopes. We want to inspire dreams. So thank you guys for watching, and I definitely appreciate the rock submitters, our Patreon members, and our YouTube members. Thanks a lot, and have a great week, everyone.